All right. Hello, chemistry. Welcome back. We're going to be looking at Bohr models today. So we got to figure out, okay, first of all, what is a Bohr model? Second, how do I make it? To figure out what a Bohr model is, really it's just a way of symbolizing and visualizing what our atom looks like. So seeing where those protons and neutrons are and seeing where those electrons are. All right, but how do we make it? That's the big question we got to ask. And we're going to be using carbon as our example today, just because that's a pretty simple one. Like I said, we use it a lot in this course. Before we can even begin to visualize and draw out our atom, we have to answer this first little question down here. So if you look at the bottom, I want to know how many protons, how many neutrons, and how many electrons are in my carbon atom. And all my answers are right here, taken straight from the periodic table. So you can see that this atomic number is 6. Now, something to remember going back a little bit earlier in the unit is that your number of protons and your number of electrons are the exact same as your atomic number if it's an uncharged neutral atom, which is what we're working with. So if my atomic number is 6, that means my number of protons is 6, and my number of electrons is 6, which makes it really easy for us. Only thing we have to figure out is how many neutrons do I have? That's what I need to know. And to do that, you want to look at, okay, well, what's my atomic mass? And for carbon, it's 12. All right, now we know already that the mass is the protons plus the neutrons. So if I take this mass number 12 and subtract the number of protons, which is 6, I'm going to know how many neutrons I have, which in this case works out really nicely to where I have 6 neutrons. So I have 6 of each thing, which is great, and we love that. But we still need to figure out, okay, how do we draw it, right? So I'm going to grab my little pen tool. When we're drawing an atom, we always want to start with that nucleus. So there it is right there. That's the center of my atom. That's my nucleus. We know that inside the nucleus, we have only 2 of our subatomic particles, my protons and my neutrons. So I have 6 of each. So all I'm going to do is I'm going to write, okay, I have 6 protons, and I have 6 neutrons. So now those are in there. That's all that's in my nucleus. That's done. We're good. Nucleus we can leave behind. Where it gets a little bit trickier is when it comes to, okay, well, those electrons we know are floating around in that cloud outside. How do I draw those? And the answer is with what we call electron shells. So those shells are going to be going around the nucleus. So here's one shell. And we can add more and more shells, but first we need to kind of see, okay, well, how many electrons go in each shell? And that's where this handy rule I have up here comes in. So we have the 2882 rule. This means that this first shell can only hold up to 2 electrons. Second shell can only hold up to 8 electrons. The third shell can only hold up to 8 electrons. And that fourth shell can, again, only hold 2. And we're not going to go past the fourth shell because it does get more complicated. We really only need to work with certain elements when we're in chemistry for this class's sake, so we're just going to stop there. But that makes it pretty easy, so the 2882 rule, so at least now I know how I can put my electrons in there. I have 6 electrons. I know that that first shell, I can put 2 of them in there. So I'm going to say, okay, here's 1, here's 2, and we just draw them as kind of little circles. They do kind of, if you can make it symmetrical, that's great because our atoms love to be balanced. So now I've used 2 of my electrons. I still have 4 more that I need to put in there. That first shell can't hold anymore, which means I need to add a second shell. All right, and like I said, I have 4 more. That second shell can hold up to 8. That means I can fit all 4 of those electrons in that shell. It doesn't have to be totally full, not a big deal. It's more stable if that outer shell is as full as it can be, but we don't have that many electrons. So we're just going to stop there, and this is what my Bohr model for carbon looks like.